So this video is the first video for Module 2, and we're going to start with Module 2, Part 1, which covers linear equations in two variables and finding the slope of a line. Please make sure you are completing the guided notes as you follow along with this video. So the first thing we need to introduce is the Cartesian plane, named for Rene Descartes. He was also a philosopher. You may also hear this called the coordinate plane or the XY plane. And this is how we will graph equations in two variables. We have our x-axis, which is our horizontal axis, and our y-axis, which is our vertical axis. We have an origin. Our origin before, when we were graphing on a single number line, was 0. Now our origin is going to be 0, 0, where we have our x value is 0. So our x value is 0 and our y value is 0. And this is called an ordered pair, but I'll talk about this more on the next slide. It's broken up into 4 quadrants. In quadrant 1, x and y are positive. In quadrant 2, x is negative, right? Here's our x values that are negative, and our y values are positive. In quadrant 3, both our x values and our y values are negative. And in quadrant 4, our x values are positive, but our y values, those are going to be negative. It's important to note that our quadrants are numbered counterclockwise. So the way that we can find any coordinate on the Cartesian plane is with an ordered pair. So to define an ordered pair, what we do is we enclose our numbers in parentheses and separate them with a comma. The first number is always going to be our x coordinate, and the second number is our y coordinate. It's alphabetical. So if I wanted to plot the point 2, -1, that would be when x, here's my x-axis, here's my y, when x is 2 and when y is -1. So where x is 2 and y is -1 meets up, that would be the ordered pair 2, -1. So let's go ahead and plot the following points, and maybe I should label a little bit more of my coordinate plane before we do that. So if I'm going to plot point A, that's where x is -1. So I look on my x number on my x-axis, and here's where x is -1. And I also look for where y is 4. So where those two lines meet up, where y is 4 and x is -1, that's going to be right here. So this would be our point A. For B, I'm going to go where x is 2 and y is 0. Now, y is 0 right on our x-axis, right? This is 0. So this would be point B. C is where x is -5. So x is -5 down here. And y is -3. So here's where y is -3 on this line. That's where those two lines intersect. So that would be our C. And then D is when x is 3 and y is 6. So that would be this point right here. So quick notes about points on the x and y axis. If a point is located on the x-axis or the y-axis, one of its coordinates is always 0, right? On the x-axis, it's y equals 0, and on the y-axis, it's x coordinate equals 0. We'll talk about these later when we're graphing lines as x and y intercepts, so just a hint of what is coming up. So before we were working with equations in one variable, now we have upgraded to 2. So any equation can be written in standard form, ax plus by equals c, where a and b and c are both real numbers and a and b aren't 0. Because if a was 0, our x term would go away, and if b was 0, our y term would go away, and if both of them went away, then we wouldn't have any variables, right? And this is called a linear equation in two variables, and the graph of any linear equation is a straight line. So we might have lines that look like this or this. They could be vertical lines or horizontal lines, and we're going to talk about that as this PowerPoint goes on. So Let's start by filling in the table for the equation below and substituting in the given x and y values, and then we'll be able to graph this line, right? We need to figure out how to graph this line. So if x is -1, I'm going to substitute that in for x. And that'll allow me to solve for my y value. So 2 times -1, that's -2, plus 3y is 6. I'll go over here to solve it because, of course, I didn't give myself enough room. We add 2 to both sides. I have 3y equals 8, so y is 8/3. That's a fraction. That's okay. We can still plot that point, right? It's a little bit more than 2. It's 2 and 2/3 would be a way to think about it. So when x is -1, y is 2 and 2/3. Here's 3, here's 2, so it'd be somewhere kind of right there. Just do your best. So now I want to know what happens when x is 0. Well, when x is 0, 2 times 0 is going to give me 0. So I'm left with 3y equals 6, so our y equals 2. So when x is 0, our y value is 2. Eventually, we're going to call that our y-intercept because that's where it crosses the y-axis. Now I want to know what happens when y is 0. So this is my y values. 2x plus 3 times 0 equals 6. 2x equals 6, so x equals 3. So now I know when x is 3, my y value is 0. We're going to call that our x-intercept because it's where our graph crosses our x-axis, and you can label those axes if you want. Now let's take a look at when x is 2. I've got 2 times 2 plus 3y equals 6. That's 4 plus 3y is 6. If I subtract 4 from both sides, I get 3y is 2, so y is 2/3. So when x is 2, y is 2/3, about right here. We can kind of start to visualize the line that's forming. Lastly, let's take a look at when y is 5. So I substitute that in. I have 2x plus 3 times 5 equals 6. 2x plus 15 equals 6. So I have 2x equals -9 when I subtract 15 from both sides. I divide both sides by 2, again running out of room. So x is -9/2 or -4.5. So when x is -4.5, so right around here, y is going to be a +5. So let's go ahead and draw this line, knowing that every single point on this line is a solution to our equation. Every single point makes this equation a true statement. Now, I plotted 5 points here. Typically, when we're graphing a line, I need 2 points, because if I had 1 point, there are any number of lines I could draw through that. But if I have 2 points, there's only one straight line I could draw through that. So we typically want 2 points, and 2 special points we can find are going to be our x and y intercepts. So I'd already mentioned x and y intercepts, but here's a formal definition. So the x-intercept of a straight line is the x-coordinate or of the point where our graph crosses the x-axis. So here our x-axis is something negative, maybe -3. So we say our x-intercept is -3, 0, because here our y value is 0. Our y-intercept is where our graph crosses the y-axis. Here it's something positive, maybe it's like 2, right? So this will look like when x is 0, y is 2. In order to find our x and y intercepts, we need to substitute. So in order to solve for our x-intercept, we let y equal 0. And in order to find our y-intercept, we let x equal 0. And this allows us to find 2 points on our line, and we can then graph the line, which again, every single point on the line is the solution set to this linear equation. So here I have 3x minus y equals 3. So I'm going to let y equal 0, and I'm going to let x equal 0. When y is 0, I have 3x minus 0, because I'm substituting 0 in for y, is 3. That leaves me with 3x is 3. I divide both sides by 3 to get x equals 1. So this gives me the ordered pair 1, 0 for my x-intercept. So when x is 1, y is 0, this is my x-intercept. Now to let x equals 0, I have 3 times 0 minus y is 3. I get negative y is 3. Now the y looks like it's by itself, but it's got that negative hanging around. So I can either multiply or divide both sides by negative 1. So I get y is negative 3. So that ordered pair is when x is 0, y is negative 3. So that would be here, when x is 0, y is negative 3, and when x is 1, y is 0. Those are my intercepts, and that allows me to kind of visualize what this line is going to look like. It looks like it goes up 3 over 1. All right. This would be the graph of my solution. Let's do a couple more examples where we find the x and y intercepts. So we're going to follow that same pattern where I let x equals 0 and y equals 0 to find our intercepts. When x is 0, I have 3 times 0 minus 6y is 12. That gives me negative 6y is 12, so y is going to be negative 2. When y is 0, I have 3x minus 6 times 0 equals 12. 3x equals 12, so x equals 4. And what I want us to get in the habit of is writing these as ordered pairs. So I know when x is 0, y is negative 2. And when x is 4, y is 0. Remember, our x always comes before our y. So let's graph these. So here I have when x is 0, y is negative 2. And I'm like labeling them. And then I have when x is 4. Let me zoom back out. Don't know how that happened. 1, 2, 3, 4. Y is 0. So this would be my new 2 points that I can draw between in order to graph our solution set. So for these next two examples, I still want us to find the x and y intercepts, but I want us to note that even though these are equations in two variables, only one variable is represented. So let's see what happens when I let y equal 0 and I let x equal 0. And our equation is x equals 4. You can kind of think of this as x plus 0y equals 4. So I'm going to substitute in for y. Well, x plus 0 is 4. I get x is 4. That's not super exciting. It looks exactly like what I had before, but now we can think of it as an ordered pair. So when x is 4, y is 0. This point right here. Now, what if I let x equal 0? Well, that is going to be 0 equals 4. But wait, this is a false statement. What does it mean when I have a false statement? Well, it means I have no solution. So maybe this means that there is no y-intercept. Well, in order for something to have no y-intercept, that means it can't cross our y-axis here. So it would have to be parallel. Is parallel a line? We can recall back from previous math courses. So parallel lines don't intersect. This line is true as long as x equals 4. And it doesn't matter if y is 3 or negative 5, right? As long as x equals 4, that point, that ordered pair is going to be in my solution set. So our graph is going to look like this. It's going to be a vertical line with no y-intercept. So this was when x equals 4. What if I have y equal to a constant? What if I have y equals negative 6? And we try and find our x and our y intercepts. So if I let 0 equals negative 6, that's a false statement, right? That tells me there's no solution. That tells me there's going to be no x-intercept. Interesting. But if I let x equal 0, I still just have y as negative 6. So when x is 0, y is negative 6. 1, 2, 3, 5, 6. This point right here. So I want to find all ordered pairs that are solutions. And so for this, I just need to have a y value of -6 in order for that ordered pair to be my solution. So it doesn't matter if x is 2, it doesn't matter if x is 3, 4, 7, right? As long as my y equals -6, it's going to be a solution to this equation. So my graph is going to look like a horizontal line. And it's parallel to my x-axis. They never cross, which is why there is no x-intercept. The 4 lines we've just graphed were all linear equations, but there was something different about all of them. And what was different about them all was their slope. So when I talk about slope, we've got 4 different types of slope. We have positive slope, that's when my graph looks like it's going uphill. We have negative slope, that's when my graph looks like it's going downhill. We can have zero slope, but be careful not to say no slope. It has slope, it's just that that slope is 0, right? If I put a ball on it, it wasn't going to roll anywhere. And then vertical slope is undefined. You know, if I put a ball on it, it would just like fall to the ground. And we're going to cover why it's undefined in a little bit. Again, it doesn't have no slope. It's just that that slope is undefined. So we need a way to calculate our slope. And we define slope as our vertical change or over our horizontal change. Typically, you'll hear that referred to as rise over run. So rise would be my change in y, change being difference, so that's why we subtract, over our change in x. So I'm going to have our 2 y values, the difference of those over our 2 x values. This is the formula for slope. So thinking back to this undefined example, let's say this is the line when x equals 5, and I've got 2 points on here, right? I have when x is 5, y is 3, and when x is 5, y is 1. And if I was to calculate the slope of these, which would be my change in y's over my change in x, what you might notice is I'm going to have 3 minus 1 over 5 minus 5. That gives me 2 divided by 0. Can I divide by 0? No, this makes us divide by 0. So this would be undefined because we can't divide by 0. So let's go ahead and calculate a couple more slopes using this slope equation. So I like to start by labeling all my points to stay organized. My x1 goes with my y1, my x2 goes with my y2. It doesn't matter which points your x1, y1, and which points your x2, y2. I just tend to go in order. So I'm going to take my y's minus my x's. So here I'm going to have 7 minus a -1 over -4 minus 2. 7 minus a -1, that becomes 7 plus 1 over -6. 8 over -6, so I have -8, 6. This is going to look like it's going downhill. And I could simplify this fraction and get back to where I was. Let's do this again, another example, x2, y1, x2, y2. I'm going to look at my change in y's, so I've got 5 minus 4 over 5 minus 1. That gives me 1/4, right? So I have a positive slope. It has a rise of 1 and a run of 4, right? So that's how we're going to be calculating our slope. Friendly reminder, because this is a sticking point I want us to remember, that any equation that looks like x equal to some number, right? It's going to look like a vertical line, and it's going to have undefined slope. This is the line when x is 3. Any equation that looks like a horizontal line is going to have a equation of y equals some number. In this case, the line is y equals 5. And this is going to have 0 slope. So vertical lines have undefined slope, and horizontal lines have 0 slope. Now, what if I didn't want to calculate the slope using the slope formula? Is there another way I can determine the slope of a line? And there is. That is slope-intercept form. So the slope-intercept form of a non-vertical line, meaning a line that doesn't look like x equals some number, is going to have slope m and y-intercept b if we are able to isolate that y. So if I have an equation like 3x plus 2y is 12, I don't know the slope of this line. I don't know the y-intercept just by looking at it. But if I solve for y, so that'd give me 2y is negative 3x plus 12. Y is negative 3 halves x plus 6. Right now I've isolated my y. Now I know my slope is negative 3 halves for this extra bonus example, and my y-intercept is 6. When I know my slope, which is my rise over run, and I know my y-intercept, so where my graph crosses the y-axis, I can begin to visualize what this graph looks like. So let's go ahead and graph some of these already in slope-intercept form. I'm going to have a few examples for us. So first I have y equals 4x minus 3. 4 is my slope, which we call m, and my y-intercept is negative 3. So let's go ahead and plot our y-intercept. Those all need to be negative. So my y-intercept is negative 3. Now I need 2 points to graph a line. So I'm going to use this slope to find my next point. Now it says my slope is 4. And I can think of that as 4 over 1. So 4 is my rise, and my run is 1. Well, our rise is up and down. So I'm going to go up 4, 1, 2, 3, 4, and run over 1. That's going to allow me to find another point on my graph. I can do that as many times as I want. I can go, my rise is 4, my run is 1. That's another point on my graph. Again, I only need 2 in order to graph a line. We can also do it in reverse. I could go down 4, 1, 2, 3, 4, and over 1 the other direction to find yet another point, right? So this would be the graph of the line. Y equals 4x minus 3. So I'm going to switch colors, and we're going to do this again. And this is a skill we're going to be practicing a lot in class. So let's switch to orange because I like orange. So here I have y is negative 2/3 x plus 4. My slope is negative 2/3. So that means my rise is actually negative. So this graph is going to look like it's going downhill because it's got negative slope. And my run is 3. And here my y-intercept is 4. So let's go ahead and graph our y-intercept here, which is 4. But now you'll see my slope is going, my rise, instead of going up, it's going to go down. So my rise is 2, negative 2. So we're going to go down 2. And then my run is 3. Our run is always to the right, even if our slope is negative. It's always to the right. So I'm going to go over 1, 2, 3. Let's do that again. I can go down 2 and over 1, 2, 3. And look what I found. I even found our x-intercept when x is 6, y is 0. And I can go ahead and graph this line right here. And every single point on this orange line is a solution to this second equation. So let's practice graphing some horizontal lines. I have when x is negative 2, so this is where x is negative 2, meaning every single point where x is negative 2, no matter what its y value is going to be part of the solution. And this has undefined slope. And then when y is 3, 1, 2, 3, every single point where y is 3, no matter what it is going to be a solution to this equation. So it has 0 slope and looks like that. Its graph is a horizontal line. So let's take these equations in standard form, put them into slope-intercept form, that y equals mx plus b, and then state the slope and the y-intercept. So we're going to want to solve both of these equations for y. I subtract 5x from both sides. I get negative 2y is negative 5x plus 8. My 5s never look good, do they? I go ahead and divide both sides by negative 2. I get y is negative, no longer negative, but a positive 5/2. X, 8 divided by negative 2 is negative 4. So here, my slope, or m, is 5/2, and my y-intercept is negative 4. For example 2, I'm going to go ahead and subtract 1/2 x from both sides. I get negative 3y is negative 1/2 x plus 6. I'm going to go ahead and divide both sides by negative 3. So I get y equals negative 1/2 divided by negative 3. So if I have negative 1/2 divided by negative 3, remember when we're dividing fractions, we keep change flip. So we keep the first fraction the same. We change from division to multiplication and we flip that second fraction. That's going to give me a positive 1/6. 6 divided by negative 3 is negative 2. So here my slope is a positive 1/6, and my y-intercept, or my b, is negative 2. Last but certainly not least, if I'm given a point and a slope, can I graph that line? Of course I can. So what we want to do here first is graph that first point and then use our slope to help us find our second point. So my slope is negative 4. Let's write that as negative 4 over 1. So I know my rise and my run. So when x is 3, y is 1. So this is my point right here when x is 3 and y is 1. And my slope is negative 4. That means I'm going to be going down 4 over 1. Down 4 over 1. And a good way to gut check this is, okay, this is negative slope. It's supposed to look like it's going downhill. And our graph definitely does. So every single point on this is a solution to this equation. And we'll be talking in our next video about how to find an equation given just a slope and a point on the line.